Hello and welcome to the ipXchange community. I'm Tim Weeks. Today I'm talking to Rolf Noteboom, who is the CTO of OneThinx, and they are an IoT network hardware provider. And we're going to talk about why you'd want to use OneThinx hardware, and in particular why you would be interested in the LoRaWAN networking protocol. So that's a wide area of networking protocol that people might be familiar with, they might not, but is an alternative to cellular networking coverage for IoT devices typically. So Rolf, delighted that you can join us on the ipXchange channel today, and welcome.
Yeah, thank you. Welcome, Tim. I'm glad to meet you, and interested and excited as well to tell more about our module and LoRa.
Well, indeed. Absolutely fantastic. So let's have a talk first about LoRa or LoRaWAN. So tell us about some of your customers. Why are they choosing to use LoRaWAN, which is the networking protocol that your module supports? Why are they choosing to use that rather than, for instance, Wi-Fi, which is well known, or mobile networks, cellular coverage, which is also very well known, LTE or 4G or whatever?
Yeah, exactly. So LoRaWAN really fills a gap in the market. So, for example, you need to have data transferred over several kilometers, which Wi-Fi cannot do, which Bluetooth cannot do, and you need some data to be transferred with a small battery. So, and that's where, really LoRaWAN comes into play. So, you can have small package of data, but over a long range. So, for example, if you want to measure, if you have fields with crops and you want to measure the soil humidity, or you want to measure temperature, then you can put out the sensors in the field, put a small battery in it, and send it over LoRaWAN. And that's easy to set up as well for the farmers, for example, for the people who use it. They can use their gateway, plug it in the socket, and then set it up. It's
and what
easy to
kind
do.
of range are we? What kind of range are we getting?
Yeah, several kilometers. It can go up to, depends on if you, for example, if you have a line of sight, there are some interesting use cases, not use cases, but experiments with an air balloon where they did a range test, which was like 1,000 kilometers. That's not a good use case.
No, that's,
It proves that you can send a long range just with a really tiny amount of power, because it's somewhere around 10 milliwatts. So that's almost nothing.
Yes, very, very low for an RF. Yeah.
But for example, if you have sensors in the field, you can easily do 5 kilometers, 10 kilometers. You can do as well. Depends on the situation.
In terms of the data bandwidth, I mean, this is typically, if it's as you say, in an agricultural example, it's sensors sending pretty small amounts of data. LoRaWAN can quite easily cope with those, that kind of workload.
Yeah, exactly. It can send up to, depends on the region where you are, but it can send up to 20 to 50 bytes a time. But that's generally more than enough for simple measurements like temperature, humidity, pressure, whatever you like to measure. So there are lots of use case where also for monitoring, for example, people in the Netherlands who monitor the dikes, they need to go out there and check if they see cracks or whatever. And now they can put sensors on several places and monitor if there's something shifting or pressure, etc. So there are lots of use
case. Yeah, and so and tell me about how the network itself is set up, because in the case of a mobile network where you're using LTE or 4G or whatever, then that network already exists. The mobile network operator has set up all the masts and the base stations, so that's all done for you, and you just have your SIM card, you plug it in, and then you connect.
Yeah.
So the network is set up and operated and managed for you by the network operator. How does it work?
So LoRaWAN, that's interesting, because with LoRaWAN you can use networks which are already being deployed. For example, in the Netherlands we have KPN, but also several.
That's a network operating company.
That's a network operator in the Netherlands. So you can make use of them. They have several gateways, a few thousand in the Netherlands, I guess, currently. So you can use their gateways.
Yes.
But you can also very easily set up your own gateway, and yeah, that's interesting because people don't want to always rely on an external network. They want to manage their own network. They want to manage their own scale. They would want to scale up their network, put more gateways. And that's really easy with LoRaWAN. So, for example, you can buy a gateway for few €100 within the socket connected to internet, and then you're ready. And then you have your own network, which is, yeah, it's not hard to maintain as well.
Yeah. Yeah, absolutely. Okay, very good. So there we are. So that's LoRaWAN. So it's this wide area network. It's free to use once you've set it up. You're not dependent on the mobile network operator as you are with 4G or LTE or whatever. And it operates at extremely low power. Which is ideal for the sensor devices, the edge devices that were that operate at extremely low power, which is very good for battery powered use cases you were describing, agricultural examples. So it could be livestock in the fields, or it could be, as you say, monitoring soil humidity or whatever. So there we are. So that's the case for LoRaWAN. So when you're implementing a network, then you're going to need, as you say, the gateway, which can be available commercially for, as you were saying, a few €100 or dollars. And you're also going to need edge devices. So the devices that attach to sensors that are attached to your cows in the field, let's say, and so this is where OneThinx comes in, I think. So you supply a module for this. Can you tell us a bit about that?
Yeah, so I can tell about the module itself.
Yeah.
This is our module. It's
Okay.
here on a development kit.
Yeah. So it's about the size of the palm of your hand. That's the development kit, which is that size, and then the module is at the top of at the top of that kit.
This
top of the board
part is the module itself.
Yeah,
I can get one in a second.
It's pretty small.
It's pretty small. It has also an antenna at the top. It has the module itself. We have two versions, one without antenna, one with antenna. This is a version with antenna, of course. And this version is really easy to use because people can use it, hook it up on their PCB. This is our development kit, but they can use their own PCB, and we can support this in that as well. And people can easily implement it and make it work without doing a lot of effort, because our stack is integrated, the radio protocol is integrated. We have a lot of examples which users can get from the internet, and they get set up in like under an hour. They have an example up and running.
Yeah. Because the electronics industry loves the phrase plug and play, and we at ipXchange we often wonder about what does plug and play actually mean. We get the plug bit, but can is it actually just you plug and then you play? Not always the case. You're saying within an hour, let's say, of plugging in, you can be sort of connected with your network and sending data over to the network.
Yeah, it depends as well. If you're really handy in doing programming and setting up the stuff, then you will be a bit quicker. And if you dive into it from zero, then it will take a bit more. But it's not really hard. And for example, if people want to send a message over LoRaWAN, we have it all set up so they can use 3 commands, which are LoRaWAN init. Then it initialize the module, LoRaWAN join. Then it joins the network, and then it can tell LoRaWAN send, and then it sends out the data. So it's just really 3 commands which are needed to send out the packet. And yeah, that's quite convenient to do. And even if the users are having a hard time and struggling, we're here to help. So
Sure.
we focus on support as well.
Absolutely. So, so our members on ipXchange, if they get hold of your evaluation kit and they're starting to work with it, what kind of development environment will they be working in when they're configuring your module?
Typically, we work with Visual Studio Code because that's quite flexible. A lot of users, a lot of customers and engineers know how to use it, and it's pretty major. And you can put a lot of plugins and everything.
Yeah, okay.
Basically, all
so very standard environment that people are familiar with. Yeah.
Yeah, and they can shape it as well, use their own programs with it. So it's fairly easy to set up as well.
Yeah. And your module, as anyone who goes onto OneThinx.com, they can find lots of information about the module. But it's based on a Semtech chip for the RF functionality and a PSoC 6 microcontroller for the system control. Do your users, in many cases, does the PSoC 6 end up being the, if you like, the host controller for their entire application?
Yeah, for most for most the use case, we have our customers using the PSoC 6 for the main CPU of the device. Often we don't see any other CPUs, but it's possible as well. We have a few use cases where it's quite a complex system which is already there and which the users want to add LoRaWAN to it, and they use our module, for example, with our AT command code. So they use simple AT commands, which we provide as well. We can put them in firmware as well if we deliver our module, but users can download it as well in the module, and then they can just use simple AT commands and talk with their own host CPU to do the LoRaWAN functionality.
LoRaWAN is the main means by which data is uploaded from the sensor device up to the internet via the LoRa gateway. But the module also includes some Bluetooth networking capability. Why is that? What's the role of the Bluetooth?
So we got Bluetooth initially as a bonus because it's on PSoC 6, but it turns out to be really interesting. That's because of you have the high data rate, a lot of data you can use, and we especially see that for example key provisioning or configuring of the device. So also we have examples where users want to collect data, not only send it over LoRaWAN, but also collect it in the device. For instance, when the network is down, the device keeps on collecting the data, and then the users comes along and pick up all the data in another time, another moment, and then get all the data via Bluetooth.
Yes.
So, and that's there as well. We see that eventually also users who are initially interested for LoRaWAN later on are willing to add Bluetooth, and then it's a matter of firmware, because we have also several examples on our GitHub site as well, where users can use these to implement Bluetooth. And again, we help there as well.
Yeah. So just as with the LoRa side of the device, you provide the networking protocol sort of ready-made for developers. Also, the Bluetooth network protocol software is also there, fully integrated into the module.
Yeah. One thing I would like to tell as well, what's maybe interesting, there are two cores in the PSoC 6. So it's M0 Plus and an M4 core. And we have the radio stack on the M0 Plus, which is isolated from the M4. So the user can upload their program in the M4, the functionality, while the LoRaWAN radio stack is running really independently from the user. Also, in terms of security, it's fully isolated. So there's almost no possibility, or it's currently fully locked. The user can open it if you like. It's fully locked from the M4, from the M0. So these are two different stacks, two different cores, which are behaving independently, and the user can send data through IPC commands. So we provide the API to send and get data from the radio module, from the radio stack.
Yeah, excellent. Yeah. So from both a security and a system implementation point of view, that dual core architecture is really helpful to developers who want to just implement the whole of their application on your module without requiring an external microcontroller.
Yeah, you don't have to set up you don't have to embed the stack, but also you don't have to care about interrupts, which are timing, etc. If you want to use another frequency, if you want to have other settings on your CPU, it's fully independent. And of course, respecting to security as well, because all the security is handled on a separate core, and it cannot be breached by the other core, which is isolated in memory as well.
Yeah. Yeah, yeah. Okay, excellent. Let's just talk about power. So, of course, it depends from application to application, and it depends how frequently the application needs to upload data. There are many factors that affect power consumption. But I mean, can you sort of say typically, or from your experience with customers, what kind of battery are they typically using with your module, and what kind of battery life are they expecting to get?
Yeah, currently what we see in general is about users want to have their sensors working for at least 1 year, preferably 2 or 3 years, and sometimes we see 5 years as well. And that's not really hard to do, because we can use lots of lithium batteries. There's different choices. We see a lot of use cases with lithium TNL. And yeah, that's a high capacity battery, which can last easily for 4 years. I have an example over here, which I can show. This one. This is the internal of a sensor, which is put in the field. We use two lithium TNL batteries for this, and this works for 5 years.
5 years. Wow. Yeah. Okay. Very good. Yeah.
And it sends data every half an hour. So this that's typically a use case which we see.
Good. Yeah, genuine low power performance. Okay, excellent. So for anyone who's interested, they've been watching our video, listening to our conversation, they're interested in implementing LoRaWAN in their application. They like the idea of a module that takes away all of the development sort of risk and difficulties involved in doing the RF design. You've handled all of that for them with your module. How do they start out with a OneThinx module? What's the best way to them to start evaluating your product?
The easiest way is just to go to our website, and we have a button for the shop. There we have several development kits, but also for the US, for EU. And we also have, no, I don't have one laying around. We also have a Sprouty development kit that's similar to this one, but it has, it's more for agriculture. So it has a simple moisture sensing device on it. But users can best go with this one. They can hook it up, all the IOs, and then download the code and get started. It's really easy.
What happens if they get if they encounter any difficulties, if they find something they don't understand, or the module doesn't appear to work? How can they get help with that?
Yeah, so I would advise them to email us. We are also on social media. We are also on Discord. So yeah, get in contact with us, and we are really happy to provide help.
So technical support is one of the big things that you like to provide.
We really focusing on giving support. That's where we see that we need to provide help, because that's where others fail. If you look at the most developers of the most suppliers of LoRa modules, they don't do any support, and that's where we differentiate ourselves. So we really do support. We like to hear from customers. We like to listen to customers and also help them. And in general, we do that. It's part of what we do. The customers don't have to pay for that. We just love to help them. Yeah.
Fantastic. That's really nice for IPXers to hear that they'd love to have support when they need it. So that's fantastic. You're based in the Netherlands, in the heart of Europe. Typically, are you providing your modules and that kind of support to the Netherlands, to Europe, or further afield?
Yeah, we currently have two versions of the modules, and we sell it over the world, but mainly Europe, but also US. So we have several customers in US. We have a US version, and we provide help to any country.
Okay, excellent. Well, there we are. That's good to hear. ipXchange members. So we've come from all over the world to watch our videos. So we've got ipXchange members everywhere, including India, China, and elsewhere. So wherever you're watching from, then please have a think about OneThinx, because LoRaWAN is a really important and useful radio protocol, and the OneThinx module is a great and easy way to get going with it and to implement it in your device. So Rolf, Thank you so much for telling us all about OneThinx today and your module and explaining LoRaWAN. It's been great to hear from you.
Thank you. It was good to be in your show, and I really liked it. Thank you.